we're going to call them the primary antibody. The primary antibody is the one you made against your protein of interest, and that's the one that is binding the antigen. And then you have your commercial secondary antibody that is going to be binding on top of the primary antibody. Why does this work? Why is an antibody binding another antibody? Well, because they are from different mammal species. So you commonly, for example, will make a primary antibody in rabbits or in mice. So you can make antibody in goats that will bind to rabbit antibodies. So you take rabbit antibodies, inject them into a goat, that's a foreign protein, so they will develop their own antibodies against any rabbit antibody. All right? So, but since the goat is a large animal, also people do it in horses or cows, so animal with lots of blood, so to be able to make a lot of purified antibody, you can purify their antibodies, and then you can chemically link them to some kind of visual reporter. Something that will light up and show you where it is. And there's a variety of things that are used, some that produce a dye, so they become colored. Some that produce light, so then they can be detected with a camera or with an X-ray film, with a film. All right? Yes, question?
I was just wondering why you don't link the primary antibody with the reporters?
Yeah. So you could. You absolutely
Excellent
could.
question. Yeah.
Great question. All right. So, but there are advantages. There are additional advantages to having a secondary antibody. All right. So, say for example that I just know how to work with rabbits. All right. So, and I'm interested in 3 different proteins. So I purify those 3 different proteins, inject them into 3 different rabbits, and then I can purify the antibodies from each rabbit. Now I have tools to recognize 3 different proteins. If I want to visualize them, I would have to take each of those, purify them to really high purity, and then do the chemical reaction with the reporter myself. Which, if I have some chemical knowledge, I might be able to do, but it's going to be a little tricky. All right? But it works. All right? If I go the other way, I can then use the goat anti-rabbit antibody and use it with my rabbit A experiment, or my rabbit B experiment, or my rabbit C experiment. So I save a lot of time. That's advantage 1. The most important advantage, though, and this is the important point I want to make in this slide, thank you to you, is that the secondary antibodies also amplify the signal. Because for every one primary antibody that bound to your antigens, you have now bound a multitude of secondary antibodies, each of them carrying a light bulb with them. So if you had only used the primary, you would get only 1 light bulb, but the addition of this second layer now brings many more light bulbs to be able to let you see it. So the sensitivity of the Western blot goes tenfold higher. Tenfold is an estimate, so not an accurate account. Okay. A bunch. So secondary antibodies, really useful. And then I can use a variety also of secondary antibodies for multiple different purposes. All right, let's go and try to apply this. So we have this problem. Let me set that up while you read. I forgot to set this one up. So we're going to do it with fingers. So we have a large protein, all right, that runs in the gel as a molecular weight of 100 kilodaltons. Right? So that's what you run in lane 1. Right? But then you take another sample of that protein and you cleave it 1/4 of the way in from the N-terminus, and then you boil that in SDS plus beta mercaptoethanol and run it on lane 2 of your polyacrylamide gel, and then you blot that onto a membrane, and then you incubate that membrane with an antibody. It tells us that it's a monoclonal antibody that binds close by, not at, but near the N-terminus of the protein X. It tells you the amino acids. Amino acids 329. All right. So you will then not stain the membrane for total protein, but you will only visualize the position of the monoclonal antibody with secondary antibodies. Right? So which of those results is the correct result that you will observe? Look at it, think about it for a moment.
And write down your answer on the paper. Commit to an answer there.
Yeah.
So A, do it in number form. So A is 1, B is 2, etc.
So what I'm going to ask you is to put your answer like this on your chest so I can see it. You're not going to be putting up. You're just going to be putting it here. 1, 2, 3, 4, 5. Whenever you're ready.
Are some people totally confused? Or go ahead and put your hands up. It's like flashing gang signs or something.
Yeah. Okay, there's no agreement whatsoever. So, work it out with your neighbors, and they will ask you again.
Definitely find an answer.
Yeah, I was thinking about the also. Yeah, and I was worried about how the
Right.
And it's a lot lighter.
Right.
Yeah.
Yeah? I was thinking too.
Well, that's what I was wrong, so when my answer sounded good in my head, I was thinking,
I like your answer too. Like, a lot of
Anything else?
So think about the gel, and then one you use a sample, and the other one you have the sample in your
Other questions? All right, so let's take another vote. So I'm going to see where all you are at this point. This time, I want you all to commit. So at the count of 3, you're going to put your hand up with your answer. All right? Ready? Set? Go. All right, so I have mostly 4s, all right? So let me go through, and that is correct, all right? So let me
And
go
with the
through.
cool thing that we just observed is learning happening in the classroom through team discussion. Because originally, y'all were all, all over the place
1s,
with
2s, and
answers.
3s, and 5s. All right, so we have this long protein, all right? And we have a monoclonal antibody that binds here, right? So this portion over here is the antigen for that monoclonal antibody. So if we take this protein and it's in a test tube, right? And we add SDS plus beta-mercaptoethanol and run it on lane 1 of our SDS gel. So it's going to be migrating through here, and it's going to be migrating at 100 kilodaltons. Then we take a separate sample in which the protein has been cleaved into segments of 75 and 25. Where does the antibody bind? The antibody binds in the same spot, same antigen. So it can only bind in here. All right? It will not bind to the 75 segment because the antigen, the star, is not found in there. Those amino acid sequences, that particular amino acid sequence is not found in this place. So when we take this protein, put it in a test tube, we have the little bit and the large bit, run it, boil it in SDS. We're going to have 2 segments at running a 75 and 25. Both are present in the gel. So they are there. If we were to stain this with a protein dye, we would see exactly that pattern, all right? We would see 100, 75, and 25. But that's not what we did. We transferred this to the membrane. And we add the antibody solution. Of course, there's hundreds of thousands of molecules in there, and they're going to be floating around. So the antibody will be able to bind to the protein of 100 kD in lane 1, and they will be able to bind to the small 25 kilodalton protein in the second lane. They will not be able to bind to the 75 kD band.
It's there, but you don't see it. It's not detected.
It's invisible because it's not being highlighted by the antibody. So we see 100 and 25. Cool? Questions? So this kind of thinking, very simple, can be just layer on a little bit on top of a little bit more complexity to give us amazing amount of detail and insight about how the cell works. So that's what we're going to be doing over the next, over the rest of the course, all right?
And one thing about this problem is that it illustrates, these problems are complex and you have to read them carefully. So if this was a monoclonal antibody, or if this was a polyclonal antibody, that would mean that it recognized lots of antigens along the protein. And for homework tonight, on your own, predict what this gel would look, what the Western blot would look like with a polyclonal antibody. We can talk about that on Canvas.
So now just remind you that there's pre-class reading for next lecture. Please be sure to look at that. And homework is ready on Canvas. Thank you all.
Thank you.
Thank you.
Nice meeting you.